Okay, to figure out the grams of product that were obtained, I'm going to take the mass of the filter paper and product and subtract the mass of the filter paper. So go ahead and do that if you haven't already. And there's the answer to that one. Then for the next part, we know that whatever aluminum ion was present in the 20 mils of solution was supposedly converted into aluminum phosphate. So what I can do is I can work from the amount of aluminum phosphate that I have, which is the 0.418 grams, and I can work from that to the grams of aluminum that were in there, because all of the aluminum that's present as aluminum phosphate was originally in the solution. So go ahead, work out a way that you are going to do that. Pause this, try that problem, and then come back. Okay, this is the way I chose to work this out. I said that if I know how many grams of aluminum phosphate I made, I can look at the ratio by mass of the mass of aluminum in aluminum phosphate, and I multiplied it to get to that. There is another way to go. Okay, so I could have gone from the mass of the aluminum phosphate to the moles of the aluminum phosphate to moles of aluminum ion, and it would be a one-to-one relationship between the moles of the two things, and then using the molar mass to the grams of the aluminum ion. So if you're more comfortable doing it that way, in a way that's closer to how we do most of our stoichiometry problems, that's fine. As I said before, there's different ways to do the math, but either way you should get the same answer. Okay, so these are the error problems that I mentioned in class, and the error problems, you want to be really careful how you explain things, because you have to be very specific or people could read your answer as totally the opposite way. But if I had not fully dried the precipitate, okay, so I've got my filter paper, oops, that didn't do what I expected, got my filter paper, and on my filter paper I have the aluminum phosphate, but on the filter paper I also have a little bit of water. And so if that is true, what would be true of the experimental grams or the measured grams of aluminum phosphate? Would it be all aluminum phosphate? No. Okay, so the way I'm going to put it, I'm going to say my experimental grams of aluminum phosphate is too high. It's higher than it should be because the mass I'm getting is not just the mass of the aluminum phosphate. So I'm going to pause this and write that. Okay, but the question didn't really ask about the aluminum phosphate. It talked about the aluminum ion that was in the solution. So now if I look back to how I did my problem, okay, so this was my question too. If you did it differently, look back to how you did your problem. But for mine, I had the 0.418 grams aluminum phosphate. You don't need to rewrite yours because you can see it, but I can't on mine. Then I had grams of aluminum ion in the numerator, grams of aluminum phosphate in the denominator, working to grams of aluminum ion. So if this value is too high, I think I made more of this than I really did, then when I carry out my math here, this value will be too high. So then I need to go ahead and write that, and I'm just going to kind of continue it down here. So I'm going to pause it and write that in here. And here I was very specific and said the calculated mass of the aluminum ion is also too high. I didn't really have a bigger mass of aluminum in the solution, but the number I calculated was bigger than the mass of aluminum that was actually there. Okay, so in this one, we're saying that here's my Erlenmeyer, which really I made a little smaller than I wanted to. Here's my funnel, and here's my filter paper and the aluminum phosphate that's trapped on it. But not all the aluminum phosphate ends up trapped up here. Instead, I get a little bit of aluminum phosphate down there. Well, this means that when I compare the masses of the filter paper and product versus the filter paper, the grams that I measure of aluminum phosphate is going to be lower than it should be. So I'm going to say the measured or experimental mass of aluminum phosphate is too low. And then think about how that would affect the error, and go ahead and make your prediction, and then come back and compare to mine. Okay, the way we're determining information about the aluminum ion is by calculating it from the aluminum phosphate. So if that value is too small, this value will be too small also. Okay, one more problem. Okay, this one comes back to the solubility rules. So we're trying to precipitate calcium ion, trying to precipitate all of it, but if we think about A, with A, our calcium ion would be reacting with which one? Sodium or nitrate? Okay, calcium's positive, it's going to react with the negative nitrate. And so if we have calcium and nitrate, is that going to produce something that's aqueous or solid? Okay, aqueous. Nitrates are always aqueous or soluble. So that's not going to work. B, our calcium ion would be reacting with what? Okay, so the acetate. And do acetates tend to be aqueous or solid? They are also aqueous, so that's not going to help us to precipitate the calcium. So C, our choice, calcium would be reacting with carbonate. Would calcium and carbonate make a solid? Yes, it would. So we would need to react it with that, and I'm going to go ahead and pause this and write an explanation. You can do the same thing. And there's my answer. Have a good afternoon.